Hello everyone, I'm Juan Moncada, TA1 for the PPCR 2024, and today we're going to be talking about inferential statistics. Starting with our definition, inferential statistics involves drawing conclusions about a larger population based on a sample from that population. So let's say that we want to study the effects of resistance training with free weights versus resistance bands on muscle strength in older adults in the US. If we want to study all the older adults in the US, it will take us years, it will cost a lot of money, so the option that we have is studying a sample from that population, which in this case will be older adults from 5 states. Then, with that information, we can make conclusions and extrapolate that information to our target population. Now, let's think that we're going to run a randomized clinical trial where we're going to assign our participants to resistance training with bands and resistance training with free weights. We're going to run the study for 12 weeks and we're going to measure muscle strength and functional mobility. So before running any test, the starting point for our project is going to be our null hypothesis. We think and we believe that there is no difference between the groups. But then we want to prove the opposite. Our alternative hypothesis will be that there is an actual difference between resistance training with bands versus free weights. Difference that we are noting. Now this takes us to the next stage, which is defining if the difference or not the difference that we are seeing in our results are due to chance only or because of those results are statistically significant. That means, and the way we do this is through the p-value. So what does it mean? The p-value is usually a threshold, a number that it's been established to define if the results are due to chance only. The p-value is closely related to the confidence interval. In other words, the confidence interval provides a range of values within which we expect the true population to fall based on our sample data. That means that if we were to repeat the study multiple times, 95% of the time, our population will fall within this confidence interval. I really like this graphic that represents the connection between the p-value and the confidence interval, because what is showing us is that if the confidence interval is touching the zero or the number that represents the no effect, our hypothesis is rejected. That means that it's not significant. But when the confidence interval is not touching that zero or that number, that means no effect, which means this spectrum between the one, our hypothesis is not rejected, which in other words will claim significance. When we're doing this type of analysis, we can make some statistical errors. So on top of the graphic, we'll see supposed reality. We will imagine that the results are positive and in fact there is an actual difference between the groups. In the first scenario, we will say that the reality shows us that there is a difference and our study findings are also positive. So it's a true positive. But in the next side, in the other side, we have a negative reality. In other words, there is no difference, but we are claiming that there is an actual difference. That is a type 1 error, which is kind of dangerous because we will claim a difference when in fact there is no difference between any of the programs that we are saying. The other side of the coin will be when our reality is showing us that there is an actual difference, but our study findings are negative. In other words, we're saying that there is no difference when in fact there is a difference between the groups. That will be a type 2 error, and that's maybe not that dangerous, because if we get a negative study, it's not going to change anything in society. We're not going to change our medical decisions with this. But with the positive, the false positive, people can make changes to their diet, to their workout, to their nutritional planning, start taking medication. So we want to take care of those false positive results. And the last scenario will be the reality telling us that there is no difference, and our study findings being congruent with that result. In other words, a true negative. Once we have these concepts clear, we want to choose the right statistical test for our data. In order to do this, we want to make sure that our data is normally distributed and it fulfills the criteria or the assumptions for this matter. If that's the case, we will go with parametric tests, which is usually obtained with large sample size. But if that is not the case, if we have a small sample size, if we have outliers, we can always run non-parametric tests that will allow us to compare our data. And that's pretty much it. Then we have the table. We can use different type of tests based on the number of variables that we have and the dependent or independent variable that we are comparing.